So in this video, we will discuss the different types of alkyl groups. So first, let us understand what is meant by alkyl group and how to write different types of alkyl groups. So basically, alkyl group is generated by removing one hydrogen from alkane. If you remove one hydrogen from alkane, you will get alkyl group. The general formula of alkane is CnH2n plus 2. If one hydrogen is removed from this, you will get a CnH2n plus 1. So this is a hydrocarbon group which has a general formula CnH2n plus 1, that is called alkyl group. And these are named by replacing ane in alkane with the yl. So in alkane name, ane should be replaced with the yl. Methane, methyl, ethane, ethyl, propane, propyl, like that. Generally, the symbol R is used to indicate any alkyl group. Anywhere if you see R, that indicates a alkyl group. So most important thing is how to write a isoalkyl group. So here this is based on number of carbon atoms. This is based on a number of carbon atoms, propyl, butyl, pentyl, like that. And this is based on its structure. In case of all isoalkyl groups, you have to have this particular structure. So here, last but one carbon, it has to have one methyl substituent like this. Whenever you have this kind of structure, that is called isoalkyl group. For example, if you want to write isopropyl group, totally there must be 3 carbon atoms and this kind of structure. Isobutyl group, you have to have this kind of structure, and butyl means totally there must be 4 carbon atoms, one more CH2 you have to write. You can see, so here totally there are 3 carbon atoms and a CH3, CH, CH3. This is isopropyl. CH3, CH, CH3 structure, totally there are 4 carbon atoms, therefore it is isobutyl. CH3, CH, CH3 structure, and here totally there are 5 carbon atoms, therefore it is isopentyl. CH3, CH, CH3 structure, iso, totally there are 6 carbon atoms, therefore it is isohexyl. Isoethyl you cannot write because iso means minimum there must be 3 carbon atoms. And the next one, how to write a secondary alkyl group. In order to write a secondary alkyl group, hydrogen must be removed from a secondary carbon. So it should be CH with 2 alkyl groups. So here there is a point of attachment, one hydrogen is removed from this. So here this is one carbon chain, this is also one carbon chain. So whenever you are talking about a secondary alkyl group, you have to write a CH with the 2 alkyl groups. See, for example, here this is a CH. One is methyl group, another one is ethyl group. So totally there are 4 carbon atoms. Therefore, it is called secondary butyl. And if you take secondary pentyl, does not exist. In case of secondary, only butyl group, but a pentyl, hexyl, those groups do not exist, because if you are talking about a secondary pentyl, so pentyl means secondary means we have to write a CH with 2 alkyl groups. Pentyl means 5 carbons. Already here 1 carbon is written. So 5 minus 1, 4. So in that 4, you can take here C2H5, here C2H5, otherwise CH, here CH3, here C3H7. So this is pentyl, this is also pentyl, both are secondary pentyl. One name should indicate only one structure. But this is a secondary pentyl, this is also secondary pentyl. You are writing two structures, therefore, simply we have to say secondary pentyl should not be used. So, secondary pentyl does not exist. Secondary hexyl also does not exist, because if you are writing secondary, it should be CH with 2 alkyl group. Hexyl means 6 carbon atoms. Already one carbon is written there. There must be 5. In that situation, different distribution you can take. This is CH3 and here it is C4H9. Otherwise, C2H5 and C3H7, different combinations. So totally 5 carbons. You can take 1 plus 4, otherwise 2 plus 3, like this. So that is the reason secondary hexyl also does not exist. So this is about writing secondary alkyl groups. Next, how to write a tertiary alkyl group. In order to write a tertiary alkyl group, you have to take carbon and it should be attached to 3 alkyl groups, like this, like this. Here point of attachment, so that is hydrogen is removed from that. So how to write a tertiary alkyl group? Like this. And if you see tertiary butyl group, if you want to write tertiary butyl group, so this is carbon. Butyl means totally 4. Already one carbon is written here. 4 minus 1, 3. So methyl, 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 like this, tertiary butyl. This is a tertiary butyl. Tertiary pentyl, tertiary pentyl. So totally there are 5 carbon atoms. So tertiary, one carbon, like this. Remaining 3 are alkyl groups. So 5 minus 1, so that is 4. The combination is CH3, CH3, C2H5, like this. There is no other combination. So tertiary butyl exists, tertiary pentyl exists, but tertiary hexyl does not exist, because hexyl means 6 carbon atoms. So this is one carbon atom. So that is 6 minus 1. So that is 5. What are the combinations you can take of 5? CH3, CH3. So here that is C3H7. So 5 carbon groups, 5 carbons. So like this, 1 plus 1 plus 3. Another possibility is we can take a C2H5, C2H5, CH3, like this, 2 plus 2 plus 1. So this is indicating tertiary hexyl, this is also indicating tertiary hexyl. Therefore, so one name should indicate only one structure. Therefore, tertiary hexyl does not exist. And finally, how to write a n-alkyl group? N-alkyl group means there is no branch. You have to write a only carbon chain, straight chain you have to write, like this. So CH3, CH2, 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 1, 2, 3, 4, 5. So this is n-pentyl. So based on the number of carbon atoms, so here like this normal chain we have. So this is CH3, CH2, 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 like this. So 1, 2, 3, 4, 5, 6. Therefore, it is called n-hexyl. So this is used when all carbon atoms are present in normal chain. So if you look at all alkyl groups at once, so this is a methyl group, This is ethyl group. This is n-propyl group. You can see this is a CH3, CH3 isopropyl group. You can write the CH3 here also, no problem. So this is n-butyl group, and you can see this is iso CH2 isobutyl group, and this is a C with two alkyl groups. This is a secondary butyl group, tertiary butyl group, and all carbon atoms are present in a normal chain. This is n-pentyl, and we have a iso structure like this, totally 5 carbons, isopentyl, and this is hexyl, n-hexyl, and this is isohexyl.